You at Linoleum Innovation Festival, and tonight we're starting our lecture program. The first lecture is going to be about neural networks for artists, and I would like to introduce our current speaker, Eugene Sannikov, who is the head of Innovations and Research Department in FILM.UA Group, and he's going to tell us how we can use it, what kind of interesting methods there are, and what he himself managed to do, and maybe you have even seen it on Independence Day. During the broadcast, you can also ask your questions in comments. You can ask them after the lecture here live. And I hope you'll enjoy the lecture. Evgen, the floor is yours. Good evening. I hope you can hear me. Hello, you few fans of new technologies. Today's lecture, yes, is about neural networks for artists. Well, artist is actually a conditional name. I would because it is a multidisciplinary term, as I can say. It's not just about drawing, but I'm going to try to tell about my experience of work with the neural networks. I don't know that somebody in Ukraine media industry has huge experience, but what I managed to dig up, of course, I'm going to share it with you. The Department of Research Innovation in FILM.UA, we imagine ourselves like you can see in this picture. We work in the biggest film studio in Ukraine, FILM.UA. We're researching new technologies, which we then implement in our process. We deal with blockchain, with gaming engines. That's the special love of our that we have integration of VR, AR, and neural networks in the filming process. And we feel like the person in the forest who is looking for something, tries to bring something new, but he's also a bit lost there. And that's how I feel. Because becoming an expert in new technologies, especially technologies like AI, that's a real challenge. A bit about myself, my background is the following. I graduated from Kyiv Polytechnic University, automation of experimental research. The circle is closed, that's what I'm doing now. Also the National Art Academy, the historian of art. And also studied in general psychology in university, named after Shevchenko. I also studied for AI project management and had a brief course in Amsterdam on visual perception. I used to be an art director of Inter TV channel group for about 7 years. After that, I produced documentaries in FILM.UA Group. We made lots of docudramas. I'm especially proud of the series for Discovery on history of medicine. Over there, I learned a lot about film and filming and production process. And for almost 18 months, now we have this Department of Research and Innovations, and that's my new technologies we're studying and implementing in the process. So I guess that's it with the introduction. Now we're going to talk about the subject of our meeting. So what is this AR, machine learning, neural networks, all this stuff? The very basis is AI. That's a program which can self-learn and imitate behavior, which would be similar to that of a human. Machine learning is an algorithm which can learn itself on structured data. Who structures those data? Of course, humans do. I'm going to show you how it all works and what it looks like. A neural network, with the help of an artificial neurons, it modulates the work of human brain and learns with regard to previous experience. That's a good philosophical example which I liked in my job. I just believe that it is much more important to learn the principles of intelligence than to duplicate. And the problem of artificial flight actually was resolved only after the Wright brothers stopped imitating this flight of birds. They reject the idea of full imitation and just use the principle. And that's what we can do with human brain, the neural networks. They use the principle, but they do not try to emulate the function of human brain in full. And I'm also going to show you, just to spark your interest in the works that neural networks did, and then we're going to talk about the way they work. If you start Googling art of neural networks, AR art, the first thing that you find is the work of a team Obvious from Paris, and that painting was sold in Christie's for almost $500,000. This is called Portrait of Edmond Bellamy, and it is signed by this piece of a formula. This is a part of the algorithm that created this painting, and actually the neural network which creates similar things Young Goodfellow. And actually, there is a paraphrase there. Bellamy is actually a good fellow. The creator of this painting, that was actually a sort of homage for the author of the technology. And this is a series of works. This a portrait of Edmond Bellamy. This is a female portrait. They were created in this way. We're going to see an accelerated video now. And there is also an excellent case that I managed to see live. At every lecture where I talk about AI, this is a painting by Rembrandt, which was created by a neural network. This is not a new project, there are the old one. I saw it at Frankfurt Book Fair, where it was created. So how this worked? They took the corpus of Rembrandt works for a neural network to study, to learn, and having reworked it, it created a male portrait, of course in Rembrandt style, that never existed. After that, I mean, except the portrait itself and the image itself, of course, there was a map of light altitudes created. So thanks to that, a 3D printer on the canvas was able to recreate the volume of brushstrokes. And let's look how it looked like, this work on the project.
One of his great achievements, one of Rembrandt's great achievements, was to portray human emotions in a much more convincing way than artists had before him, and in many ways for all time.
But we haven't been using data that much in a way that touches the human soul. You could say that we use technology and data like Rembrandt used his paints and his brushes to create something new.
The first step was to study the works of Rembrandt in order to create an extensive database. We gathered the data from his collection of paintings from many different sources, including 3D scans and upscale images using a deep learning algorithm. Because a significant percentage of Rembrandt paintings were portraits, we analyzed the demography of the faces in these paintings, looking at factors like gender, age, and head direction. The data led us to the conclusion that the subject should be a portrait of a Caucasian male with facial hair between 30 and 40 years old, in dark clothing with a collar, wearing a hat, and facing to the right. From there, we started to
and we used statistical analysis and various algorithms to extract the features that make Rembrandt Rembrandt.
We took parts of the face and we started to compare them. And then, based on this, we're able to create a typical Rembrandt eye or nose or mouth or ear.
After generating the features, we were focusing on the face proportions. We used an algorithm that can detect over 60 points in a painting. We were able to align the faces and to estimate the distance between the eyes, the nose, and the mouth and the ears.
A painting is not a 2D picture, it's 3D. You can see the canvas, you can see the brushes, and that's what makes the painting come alive. A hive map is essential to make the painting a painting.
We incorporated the height map into the painting and printed on a 3D printer that uses a special paint-based UV ink. It printed many layers, one on top of the other, which resulted in the height and texture of the final painting.
It's sometimes a magical moment to see a painting for the first time, even if it's computer generated. For me, it is something special. I would have believed if I saw it in a museum that it would have been a real Rembrandt, just one I haven't seen before.
will be interesting to see Rembrandt looking at it. He will be happy that there are people trying to understand him and trying to create something out of that. So I think he will be happy.
The next Rembrandt makes you think about where innovation can take us. What's next?
Okay, I'm going to stop because we have a little time and I want to tell you a lot of things. So how does a neural network function? That's a human neuron. The point is about passing electric impulses, transferring those, and that impulse emerges in an electrochemical way, and some threshold value has to be exceeded so that the electric impulse goes from the neuron body through dendrite into axon into the final branches, and this end connects with the following neuron like that, and that you often hear in popular psychology like forming neural connections. That is actually the transfer of electric impulses for decision making. To transfer electric impulses, we understand that there are actually weights, and just a simple example how a simple neural network works. It's called perceptron. So whether should I go to linoleum to this lecture and to all lectures in general? Here is the probability of this event. It is multiplied by importance. You choose importance for self. I'm going to find out lots of new things. 1, it's a lot, 0.9. The probability is find out a lot of new linoleum is very big. I'm going to meet new people also, let's say 100%. The importance of that is 0.3, like more or less. I'm going to be bored at linoleum. Of course, you never end up bored at linoleum. The importance is highest and the weight is 0. So in the end, you decide that you're going to go that because the arithmetic weight is actually exceeds 50.5. And that means that we're going. Of course, it's going to be fascinating. And we'll go into linoleum year by year. You accumulate experience and your weights, and they had actually adjusted depending on your criteria. But another interesting thing to understand here, when we do not know the basic conditions what's going to happen, all these weights and neural networks are adjusted in a chaotic way. We choose weights, they could be anything. You're going to see it by works that I'm going to show further. And they are corrected after the first visit. Let's say after 5 years of visiting linoleum, you're going to have rich experience and also adjusted ways for making a quick decision whether you go the following time or not. Just the same, I'm going to go a bit ahead. We have this story with cars, let's say. When in childhood you don't know the marks or models of what a car is, by studying this whole data set of cars, you learn to tell them apart by colors, by lights, by various trademarks. That's also very similar to the actions of a neural network. And another example is the art project of a Japanese art photographer who put a camera on his car, who was actually making automatic pictures, and went all over the northern coast of the States. And he, by getting a mass of photos, he chose out of those for his exhibition the pictures to his taste. So therefore the neural network of the artist in the head, which makes a selection for these artistic works, is actually set to his preferences. This also illustrates the work of a neural network very well. And another example, also a simple way to understand. I don't know, maybe it's not that simple. Is maybe only simple for me, but let's say the neural network for determining numbers. We have cells, 28 by 28, that's 884, and the brightest points are actually the moments where the neurons are exactly. Let's just imagine that every pixel is a neural, and they allow to determine it by transferring information, so which number we see. It is important to understand that each of these points is a neuron, and when it gets on the eye retina, this 9 actually transfers information on, and neural network understands that this is a number, this or that number. A typical task for the neural network is detection. Let us say you have to find an object which is a part of a certain class of objects. We see a photo. Over there we find kites, humans, mountains, sea, and all that. How does the neural network know what that is? Of course, before that it got a data set. It was given pictures which were marked by people. So people marked this as a kite and put it in a folder which is called kite. about 100 pictures of these kites, and the neural network launches its algorithm, it learns, and since then each kite that is shown is defined like that. There are more complicated segmentation into classes. For example, it is used for driverless cars. Here it is important to determine not only the very point of the object, but also its boundaries, because an autopilot which manages the movement of the car, the boundaries are very important for that. So that's already a more challenging version of detection. Also generation, what we're interested in. They generate neural networks. They have emptiness at the entrance. They can generate any object that they have learned on. Let us say this is a neural network. This person doesn't exist. It generates human faces. It started millions and millions of human faces on the internet. And since then, actually, when you go to this website, you can write down the name. It is very convenient to get images of public domain. Of course, these people do not exist, and the rights don't belong to anyone, and you can use these images in presentations, collages, and the way you wish. Here is the work of a neural network, Image GPT, from OpenAI. One of the founders of the company is Elon Musk. This is a neural network which learned on millions of images, and it tries to predict the parts of closed image. Like here we can see a cat, and the neural network tries to predict what is hidden there, and it just puts different options. It could be a drop, or I don't know what that is. What is that? Or tries to put smile or feet. Neural network doesn't know what it is, but it makes predictions based from the database that it got before. The same network can do what we saw in spy movies of the 90s, to restore a face out of strongly pixelated image. This is the real original, and this is what the neural network yields. So we see that it manages this task rather successfully. What are the problems of the data sets if they're not trained well? This is actually a very fine example when neural network was trained on chihuahuas, but the small data set led to the fact that it actually thinks it is a muffin, because they're really very similar. This curious example tells us that, again, a neural network was trained on a limited data set, and a woman was penalized who was in China, and that woman was actually an external advertising on the trolleybus. And through the automatic system, she was penalized for crossing the road, the red sign. That means that the neural network was not trained on people of full height, but they were portraits, and they shouldn't have been in the data set. So that is why the situation happened. So now closer to our topic, what are artists interested in? I'm sorry for speaking so fast, because I would like to tell you a lot of things. We're interested in generative and competitive networks like GAN. This topic, you're going to see that CAN or CAN, that's actually creative and competition, and actually the clip, this contrasting language image for training, and this neural network, specialized one, they have just issued, and they are specialized in translating the textual request into images.
We will speak about that a little bit later. They're really just fantastic. There are lots of art projects made based on them. So how do the generative adversarial networks are working? Don't be scared, because I will tell quickly about that, and it will be comprehensible. There is the data set of real images which are given in the input, at the input for the discriminators, and they are trained. There is the generator, which is generating some bullshit, for instance the noise, and it is giving it to the discriminators. It is very simple. It can be compared to the certain fake currency, and when the policeman is trying to differ the real currency from fake currency. So those two neural networks are competing all the time. The network with the real data set in fact knows the main stuff of the different Indian architecture, for instance. The generator is trying to deceive this network and to get through the obstacle of the assessment of discriminator. For instance, it fails. The dataset with the real data understands that they are not similar, and it gives back the fake meaning, which means that the generator of this network is trained again and again until it achieves that this fake is taken by discriminator. So after that, all of those indicators are coming back to the settings, and this network is in permanent competition with the sample images it is trained to generate. In this way, we get those stories from the website "This person does not exist" when the faces are so precise and realistically generated that it's not that easy to differ them. Some of the signs of deepfake, as of a year or two ago, because they will vanish then. Those networks are competing with each other, and those signs will be taken away as well. These are, for instance, two not obvious hair, some of the generate abstract forms and shapes at the beginning of some artifacts which were emerging without any reason. Some of them are non-symmetrical because the neural network doesn't know all of the jewelry. It is trained with the faces, so it's not that easy for it to invent the jewelry. It's easy to define the difference in the eyes, in the hair, the lips, which are not coming together. And what's the most interesting so far, it cannot generate the correct reflection at the retina of the eye, because in the real image they are totally similar, well, with a bit of the decline because the eyes are geometrically a bit different. That is why the reflection is a bit taken back. But GAN, that is genetic adversarial network, synthesizes it very symmetrically, but if we generate it we can see that it's fake. But coming back to the theory of GAN network, as they are competing, it's not the problem to look at all of those drawbacks and to give them back to the generator network and to correct it in the future. It's all the matter of training, and the attempts of the reflection of the eyes and symmetrical eyes. 0.7 is the high probability that it's realistic, but 0.29 is obviously fake because they are totally different. Coming back to the cases, how those generative networks can be used. This is the project of Scott Eaton, the American artist. He trained the neural net on the naked bodies, which were trying to get into the geometrical shapes and the sketches of people. For instance, this is the real picture and the contour, and this one is generated by the neural network. It does not even understand that the knee or the hand or the arm should be at the front. It's a very weird shape, and it couldn't even generate the face. Still, the neural network was trained looking at the original of the poses, and it is trying to fill those contours with its guesses. So if we give some weird images in the input, it will fill with those crazy naked forms and shapes. I read the research about this project. He spent lots of machine time to train a neural network, and it's not that easy. It's in fact at the level of the scientific work what was done. But what he made more, he decided to create a multi-shaped composition in the style of Boscha or Rembrandt, and he was delving deep into the selection of those neural shapes. So he managed to generate such a complicated work, which was later exhibited at the American Art Museum and was widely known after that. Moreover, he went even deeper. He mixed the substances and liquids and gave those fluid shapes to the neural network, which tried to fill those naked figures and bodies, which it was trained with, to fill those forms and contours with those weird shapes. Another project of his is rather interesting. The neural network was trained at the primitive and some models of paper, and it was trained with those models. They have this property of soft shadow and transition. So the neural network, as it's trained with those primitives, when you give for the input those weird geometrical shapes or sketches, it is trying to make something similar of them. So we can have some things which can even bring us to such an interesting animation. If I manage to open the link. Unfortunately, I couldn't embed the video here directly into the presentation. That's why we'll need to change the app. Can I close this? So we do understand what a broad space, what a vast space for the experimental forms of animation. At the input we have in fact the board of this dance of the women's shape, and the neural network is trying to fill in this form, how it imagines creating the motion of those paper cubes or balls of primitives. He even went deeper, and he constructed a bronze sculpture. He created the shape at the 3D printer, and he used the developments of this neural network on the creation of one of the first sculptures created with the help of the neural network. This initiative maybe has been seen by all of you if you were interested in this technology. If not, it's rather interesting. The producers of Nvidia graphic cards, which were used for the games, they decided to work with the neural networks. At their website, Nvidia, they have the whole sandbox for the creators, and they created the system which looked at the similar sketches, and it recreates sketches of the real world. Let's watch 2 minutes. This is an interesting thing.
Gaussian is like a pen by numbers. Users just need to put some color on the canvas, and our deep learning network can convert users' doodles to photorealistic images. Software developers, designers, even leading artists are using Gaussian to inspire them for their projects. It's totally crazy. Artists are using our app to create new art.
What I'm excited about with Gauguin is that now I may be able to integrate a mood early on into this, an environment, not just vehicle first, environment second. And for the first time now, I'm starting to think, wow, well, I should really maybe just jam out an environment really quick and then paint something in it, because it allows me to iterate so many different ideas. It's not something that I ever imagined having at my disposal. This kind of popped on the scene and has interrupted my notion of what I might be able to use to give myself new ideas. And for me, it's about how much more inspiration can I get.
So if you're interested in that, you can get at the website and find the video research. You can find this playground or the sandbox, and with different brushes you're creating the landscape, and rather quickly it is transformed into the futuristic, well, maybe not even futuristic, but realistic sketch, which can further be used for the further work. It really speeds up the work of the concept artists. The next case. This is the story which was coming here on its own, because with the generation of the networks of those weird artwork, we would trying to put it on the canvas with the real artist. This is kind of a collaboration of the artificial intelligence and the artist, and it has the my artificial Muse name. This was a very nice project with one of the biggest researchers of artificial intelligence, Mario Klingemann. If you would like to find it at Twitter, there are lots of experiments of this person. It's very interesting. And the similar initiative in the Center of Contemporary Art named after Sergei Kuryakhin, there was a similar story. This is the acrylic and paint on the canvas by the motives of the generation of some weird abstract things of the neural network with GAN based, which I was telling about above. So this is the question where and what we should use to launch a neural network. The first point is a hardcore point. This is the Python, the language which was used to create all of them. Well, sometimes they have C++, but Python is the most convenient language of coding, and if you've got any colleagues or maybe you know it yourselves, this is the best way to work with it. But it's okay if it's too complicated for you. Google Colab gives you the opportunity. This is the free service, the cloud platform of calculation, and lots of initiatives are publishing those collabs at Google with the help of, well, let's try to launch it now, because unfortunately I had to move to somebody's laptop, so I cannot show you the pre-prepared works. If the collab is working, we'll see it. This is the code, which is totally posted here. You can deal with that, but it is launched in the similar interfaces. There are buttons of play there, or you can see in the environment perform, execute. You can use whatever you want. You can look at the keywords according to the description and to implement them. Some of the pictures uploading, and you can work from this environment using the capacity of Google. It's much easier than to create the Python environment on your own and to experiment with that. Lots of producers of all of those effects of the neural networks. For the artists, it's the best to comment those collabs, and in those links you can really read all the details, what you need to do there and which buttons to create. In this case, this is DALL-E, a very interesting generative network with the text descriptions, which is trying to recreate the work of art. And we can even see what it's trying to do here. So, picture of the waterfall under the sunset. So it's trying to guess what it can be, what it can look like as the waterfall at the sunset. In those iterations, until we stop it, it will recreate it and recreate it endlessly. A bad dimension is, yes, it's the problem. So far the resolution is not the best, and for the print it's not the best, but I'm sure that this is the matter for the future and it will become simplified much better, or even simpler. The specialized services, I recommend you to remember them. Artbreeder is the wonderful one. You should research it. As I moved to somebody's laptop, I won't be able to show my own, which I'm working at, but I will show you some of the examples. Runway ML is also a free environment with lots of ready neural networks for the artists, which you can launch and experiment with. They are well described and there are GANs there. You can recreate them from scratch without using the capacity of your laptop or computer. This is the cloud calculations. The paid version is not that expensive, so it will become even easier. So I do recommend those three services. At the Artbreeder this year, I was trying to take this interpolation, the prediction of the faces. This is the Roman Emperor Caracalla, and with the help of this service of Artbreeder, I created the reconstruction of his face. Or Mozart, who aged 20 years without a wig, and how he could look like as a picture. The neural networks are used not only for the generation of art, but also to define the realistic nature of these pictures. This is an interesting picture and case of those two retired persons who decided to define the real nature of Leonardo da Vinci, Salvator Mundi, a very famous picture which used to be considered, and still is considered to be controversial. It was bought for £45 in the beginning of the last century, and it is still going and wandering along the museums. And this is a big issue, whether it's real or not. This is a retired lawyer who had an online course on artificial intelligence, and his wife is an art curator. So why I wanted to show them? Because everything is possible, in fact. If a retired lawyer could have a course on neural networks and detect the reality of this picture, then you will be able to create the wonderful art yourselves as well. So they began to work as a couple. As his wife is a curator, she created the data set of pictures, the pictures of Leonardo da Vinci, his corpse of works which are really proven to be his is not that substantial. Those are Rembrandt's pictures, but it's not that important if they are. So they decided to divide the picture into little parts. So they made it with the home computer, PC, a very powerful video card, but it's not an industrial solution. So the neural network could not take the full scan resolution. So they divided it into segments and named it an entropy of importance. Such a wonderful notion. What's an important thing to define whether the picture is real? How the artist shows the face, the hands, some of the objects. So they divided them into sectors, fed it to the neural network for the data set of the real pictures, which are attributed to be real, and as an input they gave this picture to try to define some of the problematic zones. And really, with a probability of 90%, the neural network defined that the face of Jesus was in fact painted by Leonardo, but the hands and the background were questioned. And it's a famous story that the hands were really repainted in the beginning of the 18th century, or maybe in the 19th century. So the neural network really accomplished its task and only approved the theory of the art critics. OpenAI AI is one of the founders, is Elon Musk. They published the neural network to generate the image with the text description. This is the model of DAL-E. This is the paraphrase for Salvador Dali. And it takes the reference images and the suggestion with the description. So it has the pair of picture and text, which is fed certain pairs of image and text. And as soon as they know how to use them, it can assume, according to the text description, which is offered by you, it can offer and assume how this object looks like. For instance, in this research they mentioned that the armchair in the shape of avocado is generated with wonderful results, or the emoji of a small penguin which has the blue hat and red gloves and yellow pants, and it generates such wonderful things, in fact. So besides art, this story is really suiting the generation of some of the references, sample images, or for the concept artists. And again, I will repeat, I like to think that the calculation capacity is really increasing, and so far it looks a bit weird and awkward, but with the development of the technologies, they will become more and more sophisticated, because this is a wonderful example of a living room with two white armchairs, and the picture which shows us the Colosseum. So here we can see that the neural network is really working, and it assumes this interior. It shows us dozens of options. So if we look and assume at the cinema or the art, and I'm working on some episode, instead of inventing the quick generation of several references with this neural network in several minutes, it's very convenient, it's much better. Some of the invented and complicated situations which are not that easy to Google. The next service I was already mentioned is an art flow. It generates the portraits according to the keywords. So in fact, this is the clip network with the added GAN neural network. First, according to the text description, that's what I found, those to Goblin Wizard and fun animated character from Pixar movie, and this is what was done by me, a silver-haired sailor with the style by Modigliani. It's an interesting generation of the face. If in the input you give the new keywords, this portrait will never be repeated. Something new will be generated again and again. So I would recommend you to remember or to note it down. Please experiment with it. The only thing that the time of waiting of the generation of this portrait is rather long, up to 120 minutes. The long queue for the generation sometimes is there, and the capacity, the calculation capacity is rather significant. So please be patient, but the outcome is worth it.
But for some concept artists, for testing ideas, for quick sketches and search, that's a very interesting help. And this is from Reddit. The results that I found, there's also a neural network clip. What was put at the in the what are the input data, God knows, but I think it looks really cool. This is some incredible surrealism that we can see here. Like a really good artist, I believe. The keywords in these images here, that's foggy path leads to the Grim Reaper, and this is a realist oil painting. Some neural networks actually, if you add, this is like a life hack. It's a realistic oil painting, or for some reason Unreal Engine works very well. That's a game engine, and it gives yields very interesting effects. For example, it improves the realistic way, and also working out the brush strokes, applies this glazing gaming structures that looks incredible. I don't have an example, but still, this is life hack that really exists. And here, it's observing the clouds in Santa Fe. That's how the neural network generated what it generated. A very interesting image. The following example is a compilation of neural networks. Text-to-pic rep. That's a rep composition. The text was generated by neural network, but today we're not talking about text generated by neural networks, but still the text was generated by neural network and was is input to a clip, and then it generated image based on that. So then there was we do the editing, and this is the experimental story how it looks.
We used to kick routines and the presence was fitting. It was I, the abstract. And me, the 5-footer. I kicks the mad style, so step off the Frankfurter. Yo, Fife, you remember that routine that we used to make spiffy like Mr. Clean? A tidbit, a smidgen. I don't get the message, so you got to run the pigeon. You're on point, Fife. All the time, Tip. You're on point, Fife. All the time, Tip. You're on point, Fife. All the time, Tip. But then grab the microphone and let your words rip.
And another, this complicated example is gunplus clip. So there's the neural network which takes textual descriptions, then generates image, and afterwards organizes those transfers between the images. So you can create this weird animated spaces like that. Or this, that's a Turkish researcher via art. That's what he created.
I like to think of a cybernetic network where mammals and computers live together in mutually programming harmony, like pure water touching clear sky. I like to think of a cybernetic forest filled with pines and electronics, where ideas flow peacefully past computers, as if they were flowers with spinning blossoms. I like to think of a cybernetic ecology where we are free of our labors and joined back to nature. Return to our mammal brothers and sisters.
So, as you can see. And again, I'll come back to this slide so that you don't think that this is something inaccessible. The neural networks that you need. So where was that? So there's gun, can, and clip. So this actually various types of gun and clip. So clip, that would be text on image, and gun, that would be stylization of different weird images. And the combination of these neural networks yields this strange effects. So if you would like to experiment with this Google experimental collabs with gun and clip by these keywords, there are lots of those, and there are services which are even simpler than Google Colab. So you can join the movement. A couple more experiments. Again, clip plus gun. Here there are lots of keywords used. Underground world, fluorescence, underwater world. And this is flight through the clouds on Venus. Is it possible to use it for commercial projects now? Yes. Maybe the colleagues are going to forgive me. This is serious from our studio, and that's the from our studio. This actually the theme that you understand it, but they actually generated the background and the surface, and they wrote the image. That's all neural networks. These actors were filmed natural, not on the set of this New York, which was generated. They were simply filmed in the background of some cloth in the studio. I cut them out, I combined them with the generated background and put it through a neural network which does the brush strokes. Then I added the music. Well, that was actually very fast production. I think I did it myself in several days, because if you get hired artists or you recreated these brushstrokes and drew them in Photoshop or put them to some filters, that would be very long. And here the neural network really helped, and there are several more complicated cases from us. So that's also an interesting project which reconstructed faces of animated characters, the collaboration of the artists who redrew them in a more precise way, and the neural network tried to recreate just how I did with the Roman emperor, you know. It tried to guess the realistic way. This Uncle Fyodor from Prostokvashino, that's the mother from the same cartoon. That's Pechkin the postman. So that's Carlson, as you can see. That's the interpretation that we see. That's Mowgli. So that's the water man from you, the cartoon. That's Princess from, yes, the Bremen musicians. And God, I forgot the name. Yes, the secret of the third planet. And Neuron Love Service, well, what I talked about, restoring the portraits of Mozart and Emperor, they work according to the same principle. It costs about $10. You can upload any portrait. There are lots of very fine-tuned settings. You can experiment. You'll receive such results fast. That's another interesting generator networks which creates pixel images. Here, Pushkin Lermontov at the Jewel, as you can see. Using textual description to create an image, and then it pixelates it in the style of this art which was used for computer games of the ages. There is a collab. You can Google it. This is also a rather working story. This is a neural network which tries to model brush strokes by photos, starting from big ones and to smaller and smaller ones, because the Photoshop filter is not going to manage it. It tries really to make live brushstrokes as if the artist actually applied those. But not everybody starts from big ones. Of course, I understand this individual, but still the neural network tries to guess how the real artist would act when drawing from this photo. Well, very little time left. I'm going to tell you about defects. This is a very interesting section. So how does a deepfake work? The method of moving the face code, there's an encoder and a decoder. There's a donor image where you take the face, and there's target image where we place it. The boundaries are the mark there, and very quickly that looks like that. This is not a real Rembrandt, it's a real one. What does the encoder does? The encoder kills the initial image into noise. We cannot see anything because that image is very noisy. The decoder tries to restore the initial image after the noisy one. Of course, that's very hard to do, and it needs infinite number of combinations. In the beginning, we set weights, so it actually matches weights, so that out of this image, you could take this image out of. How does it do it? Because it knows the initial picture, and when doing that, the neural network actually comes back to the original, tries to somehow, I'll repeat myself, put out of the noisy picture the original one, and this is the same what happens with the second image. First we kill that image, and with the decoder we restore it to the real one. And what happens in deepfake? At some point we take, we'll presuppose that here so we have a trained decoder which knows how to restore a face of this fake Rambo and the real one. And we simply change places. So this set of weights is to take, so our neural network is trained for restoring this person out of the noise, and it is placed over there. So actually now, all these video materials with real Sylvester Stallone can get the face of this character. So again, we just kill the pictures, we restore them, and then we simply switch places for these two neural networks. And this story looks like that. Well, the Jim Carrey, who was inserted into Leon Keller scene. We actually did that also for commercial projects, and here we have an inspiring story, technologically very challenging, because it also works with the facial distortions.
I don't look at it, I don't touch it, I don't even know how to touch it. Oh. That's all I know. I'm telling you the truth.
Of course he did. Just do me a favor. Find out who it is.
So it is hard for the expert to tell apart this integration. For a non-expert, it's even harder because it is done very well, highest quality. This is phenomenal face swapping. Control-Shift Face, this is a YouTube channel. The guy specializes in that and uploads it. And this is a very long video. I'm not going to watch it all. We'll come back to the specific case. How this could be used in commercial way? There is a great series, Inseparable, which was put on the shelf because the Russian actor was there. Well, I'm not going to divulge all the details. Well, actually, he became a failure for this whole series, and it was blacklisted by the Ministry of Culture. It turned out to be blocked. So what is possible to be done? His face should be replaced. So we took this actor, who has more or less the same type as here, and we trained the neural network on the video material. What's also interesting, he wasn't supposed to play the role of this person. I mean, like an actor, pronounce all those cues and all scenes. He was simply supposed to give us the range of his emotions. We had to accumulate the materials. Well, he was reading some stupid things. First, the synopsis of the series, and then just telling us jokes, something. So, I mean, it doesn't matter. He was angry, he was knitting his brows, he was counting from 1 to 9, from 9 to 1, he was smiling. 20 or 30 minutes of materials are enough. And that's what I was telling you. First, the face is blurred, and then we're recreating it. So that's how the neural network sees dreams. First, it actually tries to put that face, I mean, in a week or two of work, you see the difference. This face is still blurred, and the neural network tries to restore it out of the blur. It tries to find the approach. It's just in weights, as we were actually discussing this whole lecture. So this is the result after a week or two. These are unsuccessful examples because we were training on my colleague, this neural network, and that's why the body language didn't work. So there were these weird things happening because of that. Here the story is better. That's already an actor who is of the same age, but again he didn't match by the facial features. Here you can see, I mean, it's not just the point that it is not, the age is not retouched. You can see that something doesn't work, that the features don't match, and that's the final result with the actor, which coincided with the wrinkles, and it all worked with this face. And this before and after, how it was edited. Especially, it was painful when the girl was jumping and crossing the face of this basic actor, because at that moment the neural network doesn't understand that it sees the face. So part of the face is actually covered, like you can see one eye, part of the head. For neural network, there's not a face anymore. It loses definition. There are lots of problems here. We did some manual retouching and all those things. And the following project that we used to work, that was a reconstruction of Kuzma. The concert was in Maidan just recently, and this is an actor who played in the film by Star Media, kind of a biopic about Kuzma, and he studied his facial expressions. He had his hairdo, of course, and we were very lucky that we managed to find this actor for reconstruction, because from the first or the second take he sang the whole song in full. And actually I thought I would have to work for 8 hours on this material, because it's very hard to sing a song with emotions and work it all out precisely. But as he was preparing for this role, he knew all those facial expressions and tics. Here you can see the difference, how the original sings, and these are the two takes.
Ти не сестра моя, коли не розказуй мені, хто і в чому є винен на наш.
Well, this option, the variant in the middle, is not ideal. Here we trained the neural network on Kuzma's interviews. So you just talk to the journalists, and it was not singing facial features. So here he is a bit more neutral, and the mouth isn't open well. Now, as you can see, that to the right is much more expressive. So this intermediate, this already at the concert in Maidan, that's how it looked.
Ліцензійне онлайн-казино Слото Кінг. Ти король.
Одних творців за життя не розуміють, інших забувають одразу після смерті. А є такі унікальні люди, як Кузьма. Він був модний, улюблений, визнаний. І це не минає тепер. Навпаки, у всіх амплуа співака, поета, композитора,
So we packed it in a kind of a graphics here. So we added some of the effects, VFX. so you won't have the joy to watch all of the video, but unfortunately we're short of time. Was really worried about the response of the relatives, and the film director sent me the response of mother of Kuzma. It was very hard to, because she was happy to see her son, as she said, alive. It's a very touching story she wrote, and she sent a big gratitude to the film director and to us as well for the implementation of this idea. And here we moved on a bit and experimented. We had the trained data set on Kuzma's face, and we tried to integrate it with the driver, with the I do read such lectures within the whole course of new technologies. Let us not deal with that now, but somehow why I remembered about that with the neural networks. There is such a technology at Unreal Engine that is the meta-human. This is how it looks like. This is the tool of the
I could be one of many.
主人公にだってなれる。
Je pourrais être architecte.
This is the system and the early access. We can write to the developer.
You create the narrative.
We've got only about 5 minutes left.
I
am metahuman.
So this is how we developed a digital similar to Kuzma character, and with the help of the deepfake technology we put his face onto this playing character, and this is how it looks at the video. I see the opportunity of the making this character more precise and specific with totally futuristic faces of the real characters, including the ones who are dead already. So we piled up this material on with the help of the YouTube video about Kuzma. If we had some project on the creation of the digital face of his and some game or art project, and there is no possibility to work with the actors, we could take the character in digital and to choose some of the traits and features of the face and make it more precise with the help of the neural network. That's it from me. Unfortunately, I had more to tell you about deepfake, so this will be the optimistic note to end with. I'm always showing this story in the end of the lecture. We are here. This is the graph of the density of the chips at one of the microprocessor. This is not that obvious for the non-experts in electronics, but the interpolation of this curve means that all of the technologies we are speaking about, which are already looking rather cool, in about 10 or 15 years, this curve will be exponential. It's not that easy even to imagine what will be the quality of the works which are possible in about 5 or 10 years. They will be just fantastically different. That's it from me today. Thank you. I was happy to get acquainted with you. Zhenya, thank you so much. If you've got any questions, please raise your hand and you will have the mic. Well, if no one has any questions, then let's finalize this lecture. Just in about 15 minutes, we are beginning the next lecture of ours about the case of Nova Poshta, so stay with us. And I'm reminding you that simultaneously we have some screenings at the Cinema Jovtin. That is why, if you'd like to watch a couple of cool programs, please watch linoleumfest.com. There is the whole schedule there. Thank you, Zhenya, thank you, all of you. See you soon.